Okay, so let's try to solve this question. So in this question it's been asked that a compound has following percentage composition, and it's given that aluminium's weight is 0.2675 gram, the phosphorus weight is 0.3505 gram, and the oxygen's weight is 0.682 gram. Okay, and it says that if the molecular weight of a compound is 122 and its original weight, which on analysis gave the above result, which is 130 gram, then calculate the molecular formula of the compound. Okay, so in nutshell, basically we have to calculate the molecular formula. Okay, now let's see what is given. So what to find is the molecular formula. Okay, but what is given? So they are saying that it's given the following percentage composition, but this percentage composition is given in the form of weight and not in the actual percentage formation. Okay, so we have to calculate the percentage composition. Okay, so whenever it comes to find the molecular formula, what do? We make that table. Okay, so first part of the table is, yes, correct, element. Second, percentage composition. Third, atomic weight. Fourth, it's the relative number of atoms, correct, and last is simple ratio. Okay, so how many elements are given? So 3: aluminium, phosphorus and oxygen. Okay, aluminium, phosphorus and oxygen. So we write aluminium, we write phosphorus, and write the oxygen. Okay, what about the percentage composition? We know the atomic weight. Yes, atomic weight is given 27, 31 and 16 respectively. So 27, 31 and 16 respectively. Okay, but we still don't know about the percentage composition. Do not make the mistake of directly using this grams percentage composition over here. Okay, because here we need the percentage composition, okay, by percentage and not by the in the form of weight. Okay, so this all is nothing but weights. Okay, so as I shown in the previous videos as well, if we don't have the proper weights, how can we, if we don't have the proper percentage composition, how can we calculate it? Okay, so it's very simple. What do we have to do? We have to first add all the percentage by gram, okay, which is this and this, and we have to get the total of it. Okay, so if I add aluminium weight plus phosphorus weight and also oxygen's weight, then I'll get, first of all, it is 0.2675 plus 0.3505 and 0.682. when I add this, I get the total is equal to 1.30 gram. Okay, which is also given in this question, and it says that original weight which on analysis gave the above result is 1.30 gram. Okay, which is 1.30 gram. Now how can I calculate the percentage composition out of it? So it's very simple. Let's suppose if I want to take the percentage composition for the aluminium, how can I get it? Okay, so it's very simple, that total of the molecular weight, okay, the molecular weight total is given 1.30. so if I say 1.30 has 0.2675 gram of aluminium, then 100 gram would be having X, correct, because percentage is always calculated in the out of 100. Okay, so if 1.30 gram has 2.675 gram of aluminium, then 100 gram would be having X. So if I find the value of X would be 0.2675 into 100 divided by 1.30, and my answer would be, if you solve this fraction, you get the answer is equal to 20.57 gram. Okay, definitely it's in a gram over here, 20.57, but this is percentage as well. Okay, so 20.57 percentage. Now how it is percentage? So because it is out of 100, so out of 100 gram my aluminium is 20.57 percentage. Okay, 20.57 percentage. Okay, now let's go for the phosphorus. The phosphorus would be 1 out of 1.30 gram, 0.3505 gram is my phosphorus. So in the 100 gram it would be equal to X. The value of X is equal to 0.3505 into 100 divided by 1.30. When you calculate this, you get the answer is equals to, over here let me put is equal to y. Okay, so y is equals to, it would be 26.96 percentage. Okay, and the last, if I talk about the oxygen, so oxygen would be, if 1.30 gram has 0.682 grams of oxygen in it, then 100 gram of it would be having Z. Okay, so let's find the value of Z is equals to 0.682 into 100 divided by 1.30. Okay, so value of Z would be equal to 52.46 percentage. Now if you add this and this, the overall percentage would be 100 percentage. Okay, so this is how you calculate the percentage composition. This is how you calculate the percentage composition. Okay, now let's substitute this percentage composition over here. Okay, so aluminium was 20.57, phosphorus was 26.96 percentage, and oxygen was 52.46 percentage. Okay, now we know the percentage composition and we know the atomic weights as well. Okay, what do we have to do now? We have to calculate the relative number of atoms. How can we calculate? We have to divide percentage composition by atomic weight. Okay, so it will become 20.57 divided by 27 is equal to, okay, then over here it would be 26.96 divided by 31, and here it would be 52.46 divided by 16. Okay, so we have to solve these fractions and you'll get the answer. In the first part, the answer would be 0.7618. Second part over here, it would be 0.8696, and the third part over here, it would be 3.278. Okay, 3.278. so this and this. So what do we do now? Next part is to find the smallest value out of it. The smallest value is 0.7618. So what do we do now? We have to divide every number by 0.7618. Okay, so over here it would be 0.7618 divided by 0.7618. over here it would be 0.8696 divided by 0.7618, and over here it would be 3.278 divided by 0.7618. Okay, now when you solve this fraction, you get the answer is equal to 1, 1.14 and 4. Okay, now let's assume the 1.14 is equal to 1 only. Okay, and we because we need the simple whole number ratio. Okay, so from the first, second and third, we got the value is equal to 114. Okay, so if you make the simple whole number ratio of aluminium, phosphorus and oxygen, it would be 1:1:4. Okay, so if you want to write the empirical formula, as all of these numbers are simple whole number ratio, you can write down the empirical formula. So empirical formula would be equal to Al1P1O4. We do not write the 1, that's why AlPO4. Okay, this is our empirical formula. But sir, we need to calculate the molecular formula. So we know the formula for the calculation of molecular formula. What is it? It's the molecular formula is equals to N into empirical formula, right? N into empirical formula. Now, do we know empirical formula? Yes, AlPO4. Okay. Do we know the value of N? No. But can we calculate? Yes. How can we calculate the value of N? Value of N is equals to molecular weight upon empirical formula weight. Okay, do we know the molecular weight? Yes sir, it is given in this question. What is the molecular weight? It is given that the molecular weight of the compound is 122. Okay, so okay, correct, molecular weight is given, which is 122. Do we know anything about the empirical formula weight? Yes sir, it is, if we know the empirical formula, we can calculate the empirical formula weight as well. So empirical formula weight would be equal to 1 aluminium plus 1 phosphorus plus 4 oxygen would be equal to 27 plus 31 plus 4 times 16. Okay, so the answer would be equal to 122. So 122 by 122, answer would be 1. That means our molecular formula is equals to 1 into empirical formula. Okay, 1 into empirical formula. What is empirical formula? So empirical formula is 1 into AlPO4. Okay, that's why molecular formula is equal to AlPO4. So whenever the value of n is equals to 1, this could be asked in the MCQs question as well, that whenever the value of n is equals to 1, the molecular formula becomes equal to the empirical formula. So empirical formula and molecular formula are same in the case where the value of n is equal to 1. Okay, so let's see how we solve this question. So this question was bit lengthier, but it was simple. So first of all, the compound has following percentage composition, and it was given in the form of grams and not in the exact percentage formation. Okay, and it was given the molecular weight is 122. The original weight was given, which was 130 gram. Okay, so when you add this and this, the total becomes the 130 gram, and it was asked to calculate the molecular formula. So we created this table first of all: element, percentage composition, atomic weight, relative number of atoms, and simple ratio. Okay, now after that we added the atomic weights of each, and we were not sure about the percentage composition. So what do we do in this type of question? We add all the weights given and we find the total weight. Okay, then we calculate the percentage composition by saying that if total weight has this many gram of compound element inside it, then 100 gram of it would be having x, and whatever the value of x comes, it's nothing but the percentage composition out of 100. Okay, so we calculated for aluminium, phosphorus and oxygen similarly, and we kept the values over here. Then we calculated the relative number of atoms. Okay, and calculate the simple ratio. So from the simple ratio we got the 1:1:4. That means Al is to aluminum is to phosphorus to oxygen ratio was 1:1:4. Okay, we found the empirical formula. Then by using the molecular formula is equal to n into empirical formula, we calculated the molecular formula as well, but we found first we required to calculate the n. So n is a molecular weight upon empirical formula weight. So molecular formula was given in this question, and empirical formula we calculated using this part. So the value of n came out to be 1, which is very important. It can come in the MCQs questions as well, that whenever the value of n is equal to 1, molecular formula becomes equal to the empirical formula. Okay, and that's how we solve this question. So if you still have any doubt, you can comment your doubt into the comment section, or if you have any other doubt, you can also comment in the comment section, and we'll try to make dedicated video towards your doubt. Till then, keep on studying.